Hello grade 12s. So we're changing it up slightly here with this video. So I'm still sticking with monohybrid crosses. I'm still dealing with autosomal crosses, but now we're going to be discussing autosomal disorders. So this is slightly different to what we've done previously. So remember, in the previous two videos, we were really just discussing sort of phenotype changes, a physical property that's changing about something like a fur color or an eye color or something like that. But now we're going to be delving into the more sort of fun side, or when I say fun, like, the more interesting side, which is the disorders side. And again, we're going to be sticking with autosomal disorders first. We'll deal with sex-linked disorders in a completely different video with regards to that. So please make sure you've gone through video 1 and 2. Make sure that you know what we're going through. So just as a reminder, these are the 6 steps that you need to follow when you're answering any Punnett square question, because they relatively are the same regardless of the type that we're doing. The focus just slightly changes depending on the type of question that we've got. So I'm going to pose this scenario to you as a potential question that you could get asked. So cystic fibrosis is one of the most common human genetic disorders caused by a recessive gene on chromosome number 7. An individual must inherit 2 copies of this mutated defective gene in order to be affected by cystic fibrosis. Carriers are not affected. Jean and Paul have had a genetic test done and are found to both be carriers of the cystic fibrosis gene. Use a Punnett square to determine the chance that their potential offspring will have cystic fibrosis. Include in your answer the genotype and phenotype ratios. Right, so quite a few things that we need to just sort of shift our mind towards when we're discussing these disorders. So what you need to now start thinking is that when we deal with disorders, what we are generally dealing with is with the particular genes themselves. We are dealing with things that are either functioning or not functioning. Genes that are normal, as I say in inverted commas, or genes that have been mutated in such a way that they are no longer doing the function that they are supposed to do. Remember, we go back to DNA. If you have any of those mutations that can be harmful, this is where harmful mutations start to come in. So, for example, with cystic fibrosis, not that you need to know this, but just as some background, basically what the genes related to the disorder cystic fibrosis normally do is the normal functioning regulates the salt concentrations within your cell membranes. When they don't function, it causes things to become very mucus-like, and it generally affects your lungs. So your lungs get lots of mucus build up in them, which is really what the thing of cystic fibrosis is. You don't need to know that. It would be given to you in a case study if you were to be asked on it. But that is the idea. So there's a couple of new terminology things that we need to focus on when we're dealing with disorders. So the first one was mentioned is this term carrier. What does it mean for someone to be a carrier? A carrier is someone who has inherited 1 copy of the defective gene, but is not affected by the disorder. So essentially, this individual is heterozygous. So they have 1 defective copy and 1 normal copy, 1 functioning copy of the gene, but they do not have the disorder. This is only in reference to genotype. You do not have a phenotype as being carrier. There is no such thing as a phenotype being carrier. Please understand that. The only time that you are dealing with carrier is when you are identifying the genotype of an individual. So please make sure that you don't put in a phenotype that someone is a carrier if they are. They are either normal or affected. That's really what we're saying. This concept of being autosomally recessive inherited. So technically you can have opposites of this. So you can have autosomal recessive, or you can have gonosomal sex-linked dominant. Again, either way, as the words are described, that's what they mean. So in terms of autosomal, we know that that means it's on chromosome 1 to 22. It's not a gonosome. It's not X's and Y's. When it's recessive, we know that we must have both copies in order to be affected. Same with the normal law of dominance. If you've got the dominant, which is the normal gene, even if you have 1 normal gene, much like as a carrier is, because they've got one normal and one defective, it will still override the recessive. So in order to get this disorder, you have to have 2 copies of it. So just as a note when we're referring to disorders, just know that we use the words normal versus affected. You could say does not have the disorder, has the disorder, but just becomes a little bit more cumbersome, when you're referring to things like that. So let's look back at our scenario here. So what things should you be picking out in this question before you've even gotten to what the answer is that you're going to do? What information are you extracting to help you answer this question? Well, first of all, we have to identify that this is a recessive gene. So it tells us how the inheritance pattern is going to work, the difference between recessive and dominant. The next thing is that we see that it is on chromosome number 7. That tells us then that it is an autosomal disorder. I didn't say it in the question, but you are told that it's chromosome 7. So there's no X's and Y's involved. Again, when we get to sex-linked, you'll understand why that becomes important. So you're only using letters to describe this. Then we are told that you must have 2 copies to be affected. So you must have 2 of the recessive, and that carriers are not affected. So those are important things that we needed to glean. Then, from the actual physical scenario itself, we are told that Jean and Paul are both carriers. That gives you an idea of what their genotypes are. It's helping you to identify what are their genotypes. So that's all the information that we needed to take out. And then relating to the actual question itself, what must I provide for the marks of this question that is given here? The percentage chance that the offspring will have cystic fibrosis, and then the genotype and phenotype ratio. Okay, so you should have taken out all that information to help you answer this question. Okay, so if you want to try this by yourself, quickly pause the video and then just try it yourself quickly. But otherwise, I'm going to show you how I did the answer. So in this question, it hasn't told you to use specific letters to represent the different genes. So I'm going to say, let capital D represent the normal functioning gene, and I'm going to let small letter d represent the cystic fibrosis gene, the malformed, the deformative one, the non-functioning one. Why did I do it this way around? Well, remember, it is a recessively inherited one. So I have to make the smaller lowercase letter the defective one, because the dominant is the normal one. And then we follow our 6 steps. So step 1, identify the parent genotypes. So in this instance, I would write the parents are capital D little d crossed with capital D little d. How did I get that? Well, I know that both of the parents are carriers. I know they are both heterozygous. So that's how I know that these two are both that. Nice and easy. Step 2, draw the Punnett square and then draw the alleles. So there's your Punnett square, and remember, by each square, either on the right-hand side and the top, we put each of the alleles, each of the genes to represent. Then we fill in the spaces correctly. So we take what's going to fit into this square where these two meet. Well, this is going to be big D, big D. What's going to be in this one? Big D, little d. Down here, big D, little d, and then in this corner, little d, little d. Okay, so that would be my Punnett square. Now the rest, obviously, the step 4, 5, and 6 is dependent on what the question is asking, so I'm going to give it as our particular question asked. So step 4 said identify the genotype ratios. We needed to include the ratios in it. Remember, what must we remember with ratio? The lowest common denominator, if that affects us. So in this one, the genotype ratio is 1 big D, 2 colon, have to have a colon, 2 big D little d, and colon 1 little d little d. Okay, so it's just the letters. Genotype is just the letters. I don't say carrier here, it's just the letters. Phenotype ratios. Now, let's see if you listened to what I said earlier in the video. What is this phenotype ratio going to be? So here's a reminder. That's what we had with our genotype. Remember all the information you had to take out? This phenotype ratio is then 3 normal to 1 affected, not 1 normal is to 2 carriers is to 1 affected. That is incorrect. Again, carrier only refers to genotype. So again, this is a recessive disorder. So if I look here, as long as I have 1 capital D, I will not have the disorder. I will be normal. Only if I have 2 small letters will I be affected. So please don't get tripped up by that. Please make sure that you do it just as either normal or affective in the phenotype. And then the last step, so no mention of carrier here. The last step is then the probability question, and the probability is 25% chance that the child will have CF. It's a 1 in 4 chance that the child will have cystic fibrosis. So you see, it's set out very much the same as what we did in the previous type of autosomal questions. We are just changing our thinking to, instead of this color versus this color, it's going to be normal versus affected. And then remember, you have to be very careful when you look at things like carrier, is it recessively inherited, all that kind of stuff. Right, I'm going to pose a practice question. Okay, so very quickly also just notice that this is regardless of gender. This 25% chance, it doesn't matter if the child is boy or girl, male or female, XY, XX, doesn't matter, because why? It is carried on the chromosome number 7, not on the X or a Y. So it doesn't matter. So here's my practice scenario. Pause the video, do it for yourself, and then I'm going to quickly go through the answer to make this not such a long video. Okay, I hope you've done that. Again, this one is a slightly different one, because now I've told you that it is autosomal dominant. So here is your answer. So I have said let Huntington's equal capital A and normal equal little a. So you could have used any letters that you wanted, doesn't matter, as long as they were still the same letter and they were capital and small lowercase. But now I've had to make the capital letter represent the disorder, and the normal is the recessive. It's the other way around. Why? Because it's a dominantly inherited disorder. So make sure you didn't get tripped up by that. So parent genotypes, I had one who's a carrier, heterozygous, and one who has no history of Huntington's, one who is completely normal. I draw the Punnett square, put my alleles, I fill in the spaces. So you should have gotten something the same up to this point. Again, if you switch these around, that's wrong. If you didn't quite get these ones here, go back and read to see how I got these particular ones. So answering the questions. So genotype ratio is 1 big A little a is to 1 little a little a. Remember, lowest common denominator. Although it's 2 to 2, the lowest is 1 to 1. That's what the answer should be. Phenotype ratio is 1 affected is to 1 normal. Not 2 to 2, lowest common denominator, 1 is to 1. Which therefore means that the probability question is that there is a 50% chance that the offspring has Huntington's. It's half a chance because you just need one of them. It's a dominantly inherited disorder. Yes, we do deal with dominantly inherited disorders. A lot of the times recessive is the one that people like to focus on, but they do throw in dominant disorders just to throw you off every now and then. So just remember, with a dominant disorder, you only have to have one of them to be affected. Obviously, if it was capital A, then yes, you will have this particular disorder. But if you're heterozygous in a dominant disorder, you will be inheriting this disorder. Okay, please guys, go through this, rewind, try the questions again if you didn't get them right. Make sure you can work with all of these different words: recessive, dominant, genotype, phenotype, probabilities, alleles, carrier, autosomal recessive, autosomal dominant, all that kind of stuff. You have to be very comfortable with using these words because, again, this is not difficult when you know what you're doing. Once you've figured these things out, the rest becomes easy, but it's generally this first step to make sure we get the right parent genotypes that then dictates how you're going to do in the rest of the question. Guys, if you're struggling, hit me up on Skype, or hit me up on Teams. Let's have a meeting. Let's have a talk about this. Hope you guys are enjoying the studying, and keep up the good work, guys. I'll chat to you again soon.